So, a very good evening to all of you. A very good evening, everybody, and welcome to the Hadoop Cluster with High Availability session. I am Tushar Kanti. I have a work experience of over 7 years in IT industry, and I have been working on Hadoop for over 2 years now. So, let's start with our session. The objectives of this session will be an introduction to the Hadoop clusters and different running modes for these Hadoop clusters. We will look into the configuration files, and we will try to talk about the administrative responsibilities for a Hadoop administrator. We will look into the high availability features that are available in Hadoop 2.0, and we will have a demo after that. Okay. Below this slide is mentioned our Twitter handle, our Facebook page. So you can ask us questions over there as well. We'll try to reply them. Great. So guys, let's start with the session. Okay. What are the core components in Hadoop 2.0? Okay. Basically, there are two distinct bifurcations. There is storage and there is processing. So one is the memory or the disk, and another is the CPU and memory, the physical memory. There, as I was mentioning, there are two parts of the Hadoop core components. One is primarily the storage that is related to the HDFS, the Hadoop Distributed File System. And the second part is the YARN, that is the resource manager. In Hadoop 1.0, you have the separate kind of a yarn that is a map reduce, and it is totally separate build up for processing in Hadoop 2.0 known as yarn. Okay, there are other two bifurcations. There is a master and a slave configuration in Hadoop 2.0. The master part is governed by the resource manager and the name node, and the slave part is done by the node manager and the data node. There is also a secondary name node mentioned present in the Hadoop cluster, which acts as the passive part of the name node. Okay, so what is the kind of growth you can expect? And looking into this growth, what kind of capacity you should build up in your Hadoop clusters? Okay, guys, if you have a data growth of approximately a couple of terabytes per week, and the Hadoop configuration is set up to replicate the block 3 times, then you will have around 15 terabyte of extra storage per week. And assuming 30% of the overhead to store the metadata part, you can be assuming to purchase 5 into 3, that is around 15 terabytes of hard disk space, equating to a new machine almost every week. So this is the kind of capacity planning you should be looking into. Okay, so what are the kind of recommendations for a typical slave node? Okay, so there is two kinds of configuration. One is a high performance configuration and one is a low performance configuration. Depending upon what type of work that you want your slave node to work on or to chew on, you need to provide that kind of a hardware to that node. There are two configurations mentioned. One is the general configuration and one is a special configuration. In the general configuration, it depends upon the requirement of your slave node. You can have a couple of terabytes of hard disks, that is, and you don't need to RAID them. Okay, so you don't need any redundancy in them. You need quad-core CPUs and 22 to 32 gig RAM and a gigabyte Ethernet card. In the special configuration, you have one hard disk, 2 cores, 6 to 8 GB RAM. Generally work well for many types of applications. So guys, it totally depends on your choice. A cluster with more nodes performs better than a few one and slightly faster nodes. So it is better to have more nodes than a smaller quantity of nodes with a better performance. Since the major intention is to do processing, the speed of processor does matter, but it doesn't matter in the long run or in the processing of very big files. Okay, so let's look into the memory concern of the slave nodes. See, generally each map reduce task will take around 1 to 2 GB of RAM, and slave nodes should not be working on virtual memory. Your page file should not be spilled with the RAM or the physical memory pages. So that is, if that happens, it will kill the speed of your processing. So just ensure that you have sufficient RAM to present on all the tasks, plus the data node, the task tracker Daemons, and the OS. So as a thumb of rule, the number of tasks equal to 1.5 to the number of core processors. So guys, the main concern here is you should be having enough amount of RAM in the slave nodes. Okay, so let's look into the master node hardware. The master node hardware needs to be a career class hardware. It should not be a commodity hardware. It should have a very good configuration with at least 32 gigs of RAM, RAID hard disks, dual Ethernet cards for a failover, and a dual power supply for a failover as well. So the master node does all the processing. It presents, it has all the map of where the data is stored. It presents all the job trackers or the resource managers send them to the different node managers. So these are, it has to do a lot of processing. So it has all the metadata stored for your whole Hadoop. So it has to have a very good high-end configuration. Okay. So what are the different kinds of modes of clusters that you are working with? Okay. So there are three distinct cluster modes or running modes of Hadoop that are available. The first mode is a local mode or a standalone mode. Here, no daemons are involved. Everything runs as a Java processing machine. So the standalone daemon, as I was mentioning, does not have any daemons or it does not have any Java processes running. So this is suitable for small MapReduce programs for during the development and has no distributed file system configuration as such. Okay, so the next is a pseudo distributed mode. Here, a single hardware is running all the Java daemons. So basically, this is a simulation of the Hadoop file system, and all the daemons are running on the same system. Okay, Pratik, a DFS is distributed file system. Does that answer the question? Okay, great. So there is a fully distributed mode, that is we provide a setup. Essentially, we have to set up a cluster. Configurations of all the nodes should be there, typically presenting which should be the master, which should be the slave. Then there will be a lot of other configurations you need to do to set up a full cluster up and running. Okay, so let's look into what are the configuration files that are provided. The first two files are the Hadoop and Yarn environment files, settings for the Hadoop daemon process environment. The second is the core site.xml, configurations for Hadoop core, such as the IO, and that are settings common to the HDFS and Yarn. The third is the HDFS site.xml, configuration settings for the HDFS daemons, the name nodes, and the data nodes. The third one is the Yarn site.xml, configuration settings for the resource manager and the node manager. The second last is the MapReduce site.xml, configuration for the MapReduce applications. And the last one is the slaves file, which has a list of the machines that are running as the slaves, in which essentially the data node and the node manager will be running. Okay, so this is iteration of the same thing. This is typically looking of what a Hadoop cluster looks like. There are a lot of data nodes. There is an active name nodes. There is a secondary name node, and there is a standby name node. Okay, so in Hadoop 1, the name node was a single point of failure. What happens in Hadoop 1 is 1.0 is the name node essentially runs all the metadata and manages of the fs edits file. Okay, Shri, we are discussing Hadoop 2.0 here, but this slide that I'm presently showcasing is of Hadoop 1.0. Does that answer the question, Shri? Okay, guys, Shri is asking a question. What version of Hadoop are we discussing here? And to answer that question, we are working here on Hadoop 2.0. The demo or this webinar basically is for Hadoop 2.0. However, we are discussing the shortcomings of 1.0 in this slide so that we can answer why we are moving to Hadoop 2.0. Okay. Great. So as I was mentioning, NameNode was a single point of failure. What happens is NameNode has two files, the fs image and the edits file. Now, early it is configured that the NameNode will combine these two files and then send back to the NameNode. So housekeeping and okay, so these are the working for the NameNode. It's not a hot standby. It is a standby. It is a secondary NameNode, but does not have any failover feature. You cannot fail over to the secondary NameNode. So these are the couple of tasks the secondary NameNode does. Okay. So in Hadoop 2.0, we have an active failover to the standby name node. We have automatic failover set up in the for the name node. Okay. So in Hadoop 1.0, this had to be done manually, and in Hadoop 2.0, we have automatic failover HA we can configure for the name node. Okay, so what are the new features in the high availability? The Hadoop distributed file system HA features addresses the Hadoop 1.x problems, providing the option of running two name nodes in the same cluster in active passive configuration. These are referred to as the active name node and the standby name node. The standby name node is a hot backup for the cluster, which was a shortcoming in Hadoop 1.0. It allows a fast failover to the new name node, and in the case that machine crashes or a graceful administrator initiated a failover for the purpose of a planned maintenance. Okay, so we can set up this high availability feature using two methods. One is the quorum based storage, and another is the shared storage using NFS. Okay, so what are the daemons involved for this configuration of high availability of name node and resource manager? Essentially, we'll be having journal nodes. This daemon will be containing shared edit files. Okay, these shared edit files will be used for the active name node to write and for the secondary or the standby name node to sync, to read it and sync its metadata with the active name node. There is a zookeeper service which will look into the failover controllers, and there is a zookeeper failover controller which will maintain or manage the high availability failover feature. Okay, so these are the daemons I was talking about, guys. So there is a standby name node or a resource manager node. There is a zookeeper failover controller. There's zookeeper and there is a general node. And we have data nodes, obviously, which will be running the node manager, the zookeeper, and the journal node. Okay, Shantlata has a question. When the active name node fails, will the standby name node start automatically? Yes, Shanta. That is the configuration we are looking into today. If the active name node fails, the standby name node will start automatically. Okay, so it's time for the demo. Uh, Guys, I have set up a 3-node cluster, and I have taken the opportunity of copying the Hadoop binaries and the Zookeeper binaries here. So we have a lot of configurations to do. So let's start. First of all, we'll check the, okay, so we have Hadoop 2.6.0 stable version that I've taken. And for Zookeeper, I've taken the version 3.4.6. So the first task here, guys, will be to extract the Hadoop binaries. Okay, and let me run that on all the 3 nodes. Okay. Okay, Shubhajit, you can have a recording of this session, logging into the LMS. Thanks, Shubhajit. Yeah. Oh, Let's look into that. I think this is still running. These both are still unzipping. Okay, we have unzipped here. Let's unzip the Zookeeper as well. Excuse me, guys. Okay, so we have unzipped the Zookeeper and the Hadoop file system here. Okay, and let's unzip the Zookeeper file. Oops. Yeah. Yes, Vinit, you want to say something? Zookeeper. So all the three systems we have configured the zoo. Now, guys, let's first set up the profiles. Okay. Okay. So these are the configurations related to the Hadoop. We have set the Hadoop home and the path to the Hadoop home. We have set up the Zookeeper and the path to the Zookeeper. And we have mentioned a couple of other environment variables that will be required for our processing. Okay, let us also make the soft link to Hadoop. Okay, so this is the soft link we have made and which we have used in our profile ID. If you see, we have mentioned here home Hadoop Hadoop. So this is the profile ID we are using. So if you see my present working directory, it's home Hadoop. So if I mark as Hadoop, then this will be pointing to the present Hadoop working directory which we'll be using. Let me just quickly set the profile IDs for the other two environments as well. Hadoop 2.0 and set it as Hadoop. Okay. So in the third node as well, let's log into the profile ID and we'll set here the Hadoop profile IDs. Okay. Just do this. Okay. So let's also make the soft link over here for the Hadoop. Okay, so that's done. Yeah, so we are ready to start with the configuration files. Okay, so the configuration files are mentioned in the Hadoop etc Hadoop folder. Okay, these are the configuration files that we have. Let's start configuring them one by one. Okay, so let's first look into the okay. So guys, let's first start looking into the core site.xml. Okay, so yes. Okay, so the first property is the fs.default fs property. Here we will be telling which is our URI for the default file system that which we'll be using for any client to connect. The second will be the journal node edits directory. Here mostly the journal nodes which we are talking about will keep their data here. Okay, please check soft link of S name. Okay, Feroz. Okay, let's just save this file. Let's go to CLL. Feroz mentioned a question to look into the. Okay, you mentioned the soft link of. Okay, thanks, Feroz. Thanks for mentioning. Somehow I skipped this. Looks good now. Thanks, Feroz. Okay, so we were into the Hadoop etc Hadoop course site.xml file. Okay, so we mentioned that these are the journal nodes. The journal node edits file will contain the path where the journal nodes will be keeping their metadata. Okay, so now let's look into the HDFS site.xml. Okay, the HDFS site.xml will contain a lot of configurations related to the Hadoop distributed file system, and yes, so yes guys, yeah, so the first one is the DFS name node name directory. Here the metadata will be stored for the name node. The second configuration parameter we have used is the DFS replication factor, which is set to 1, since we have just one data node mentioned here. Excuse me guys, we have DFS permission as false. We have not set up any permissions for the distributed file system. We have the name service, which is the name service ID. Here we have used HA cluster. Then we have to define the two separate name nodes which will be used in this HA cluster. Here I have used name node and S name node, that is the secondary name node. Then there are configurations for the name node RPC full FQDN address. This is for the first active name node, this namenode.hadoop.com, and the port number we have used is 9000. The next configuration is for the remote procedure call for this HA cluster that we are setting up, the secondary name node. It's the full qualified name of the secondary name node, and the port number we have used is 9000. The next two parameters are the HTTP address for the name node and the secondary name node, and the port number we have used is 50070. Okay, the next configuration is important. It contains the shared edit directory. So this QJournal files will be running on the name node, the secondary name node, and the data name node on the port 8485. Okay, the next configuration file or the configuration parameter is for the client failover proxy provider. So guys, this is required for a client to connect and to the active name node in case of a failover happens. So this is the property used for that. Okay, and we want to have automatic failover enabled, so we have switched this DFS automatic failover enabled to true. Next we have Zookeeper quorum. Now Zookeeper quorum will be running on port 2181 on all the three nodes. Okay, now next parameter is the fencing method. Now what is fencing? Here we have used SSH fence for this methodology. Fencing is a process where the secondary name node, in case of a failover, the secondary name node logs into the SSHs into the primary name node and then tries if it identifies there is the daemon is still running for the name node, then it will kill it forcefully so that it cannot affect the reads of any client for the metadata. Okay, the fencing method, the private key used here is the SSH ID array. I have already set up the SSH, the passwordless SSH for it, and we have mentioned the same ID here. Okay, for the next configuration, we will try to configure the zookeeper here. So let's go into the list. Yeah, so let's go into zookeeper slash con 5. Okay, so here is a sample of the configuration file. We need to copy this configuration file to my zoo.cfg file. Okay, we will vi this zoo.cfg file. Okay, so here we will mention the path of the data directory here. Data directory which we will be using will be Hadoop HA data zookeeper, and we will mention all the server ports which will be running this zookeeper service. So server 1 will be NameNode.hadoop.com running on port 2888 and 3888. Similarly, server.2 also as NameNode.com and port will be 2888 and 3888. So will be server 3 to data node 1 dot hadoop.com dot 2888 and 3888. Okay, so we have done the configuration part. Now let's go to our home directory and check the list here. Okay, so now we need to create the directory files which we have mentioned in our configuration. So we will make directory ha/data. Okay, and then we'll go to cd ha data and we'll create zookeeper, journal node, and name node. Okay, so we have configured our we have done with mostly our configurations except the ID file. Okay, so let's look into the zookeeper folder, and here you have to create a my ID file, guys. Okay, this is the full path. See, this is the path which we have mentioned in the configuration file of the zookeeper, which I have shown previously. If you go back here, you will see that we have mentioned the path of the zookeeper. Okay, and we have to create a my ID file here, vi my ID, and you have to just mention one here, since this is the server we have mentioned one. Okay, so now let's go to the home directory, and now I'll copy all the configuration files to the separate systems, all the three systems. Let's first go to the Hadoop configuration files, Hadoop, okay, then scp site.xml to NameNode and Hadoop home Hadoop etc Hadoop. Okay, so we will copy the hdfs site.xml here. Okay, and we'll copy the same to data node 1. This is the hdfs, and copy the yeah code site XML. So the Hadoop related files have been copied. Okay, Pawan, are you not able to hear me now? Guys, are you able to hear me? Is the audio running fine? Pawan here has mentioned that I'm not getting any audio. Okay, Pawan, can you just disconnect and connect your mic, sorry, speaker, if you're using any external speaker? Okay, great, guys. Okay, so we have to again copy the, let's move to the zookeeper in that case. Let's go to home, let's go to cd zookeeper.conf, and we have to scp the view.config file to again NameNode home Hadoop zookeeper conf file. Okay, so this is done for the NameNode. Let's try for the data node 1. Okay, so all the configurations are done. Now I think I have to do just one more thing. We have to create the same folders here. So I have to create mkdir ha data ministry parameter, then I have to create cd ha data mkdir zookeeper general node NameNode. Okay, then we'll go to the zookeeper and create a my id file. Here this is the data node, so this will be 3, and we are done. The home, and this will be again oops, mkdir ha slash data. Okay, we'll go to the ha data. mkdir will create a zookeeper chain. Okay, we'll go to the zookeeper folder and create a my id file here, and this is the secondary name node, so we will keep a value 2 here. Okay guys, almost done. We are almost there. So yeah, we have done with all the configurations I see. So now let's start the journal nodes on all the 3 servers. So we will be using Hadoop daemon.sh file. We're starting the journal nodes on all the 3. Okay, for simplicity, let me just bring it here. Okay, that's better. Hadoop.daemon.sh start journal node. Hadoop.sh start journal node. No, hi Pawan. Pawan has a question. If you can rejoin the session, you're still not getting the audio. I think Pawan, can you just log off and log into your system and check once again if you are able to get the audio then? Okay. So we'll check all the Java processes here. Okay. This here. The GPS start channel node didn't run here. Says some issue. Okay. Think is either strange. Let's look into the configuration files. Did I get all the configurations correct? Check. This looks good. Then let's go to Hadoop etc. Hadoop config and pi core site.xml file. Looks good. And import my services. Start. Okay. Okay. Site tables are good. Let's look into the HDFS site.xml. Okay. There lies the issue. I think I copied the configuration tab twice. So that might have been the issue. In that case, this should be also having the same issue. Strange. Hadoop, etc. Hadoop, HDFS site.xml. It does come. Configuration property. That's good. Okay. Let's start looking at the journal nodes once again. Yes, it's come up. So that was the glitch. Sorry guys, I had a block of configuration additional in the configuration file. I think that was the reason the journal node daemon was not coming up. Okay, great. So the journal nodes are up on all the three. Okay. Okay, great. So all the three have journal nodes started. Okay. The next task is to format the name node in the active name node. So we will format the name node format. Yes. Push. Please check the su.cfg file. It's a little slow. So this is the name node formatting. I think shouldn't be the case. Somebody wanted me to check the zookeeper config file. cmf slash super cfg. Server 1 node.hadoop.com 288887872 data node 1 Hadoop. Okay. Um, it should be Hadoop. I think in that case, zookeeper super cfg. Okay, so we see it formatting, and still taking a lot of time. So see, this is a virtual machine. So in that case, that is why you're seeing this kind of latency. When you're working in a physical server built up with the high CPU and high memory, these things will run pretty fast over there. Okay. Uh, while this is formatting, let me just SSH to the name node and change the zookeeper format.zoo.cfg. Here, this will be again. Okay, so the name node formatting is done, and to instruct the name node qgender. Okay, we are run with an error. Unable to construct the general node name node caused by invocation target configuration. Let us start a name node. Okay, so we have hit with an issue. So this is what this administration course is all about. So you know what to debug and how to debug. So this is the general nodes entry which we are trying to do. Data node 1 dot hadoop.com cluster. Let me look at the okay. So luckily we have archive here in which we have the hdfs.xml already present. So we'll try to copy this hdfs site.xml to Hadoop slash etc Hadoop file. Let's go back. Let's go to this folder and remove the HDFS site.xml and move the HDFS site.xml back to HDFS site.xml. Okay, now we need to copy this. Let's copy this HDFS site.xml to the data node 1 in the same folder. Okay. Let's try to format the NameNode again. Hi guys, Swarath has a question. Did we start the general nodes on all the three nodes? Yes, Swarath. General nodes are supposed to be running on all three nodes, and Ankush has mentioned that it is mentioned as home Hadoop in the configuration files. Let me check. Hadoop cd zookeeper config. So let's see. Uh, this looks good to me. And okay. Okay, so this is formatting, and I think I have understood the reason. There might be a couple of things you have to check again. I think we missed a configuration file. Okay, so Hadoop etc. Hadoop, we missed the slaves configuration file. We have to configure data nodes 1.hadoop.com in this file, since that is the Hadoop etc Hadoop slaves file. We have to mention data node 1.hadoop.com here. Let me also search to NameNode, and again run the same thing. To remove this, put in data node 1.hadoop.com. Okay. Okay, it has again followed an issue. Not a problem. We need to debug this. So we need to check into the permissions of this Hadoop file system. cd ha data Well, and we see the name to have 775, which looks like the same configuration. The configuration here. Okay, so let's look into the other things like modifying the configuration files. We did everything. We created the input configuration. This is HDFS course site and the file IDs. Okay, seems like the high availability is trying to play with us. And we have mentioned the slave nodes as well. Let me just chmod ha dash 2 7 7 so that it is 755 775. Looks like let's give it one more try. Just that we have given for this name node data. Hadoop achieve data name. Do we have this path here? Okay. Yep, that too. Oh, it is causing us an issue this time. So the Hadoop administrator is responsible for implementation and administration of the Hadoop infrastructure. So like the presently issue that we are running into, we need to look into all the logs that are present and what are the outcomes or what are the issues that is causing the name node to not format. See, this is one of the things you need to work as a administrator. So this is a typical work that administrator will have to do. Okay, then we have to test separate things like testing the distributed file system, the Hive, Pig, MapReduce, access for all the applications. Okay, then we have cluster maintenance tasks like backup, recovery, upgrade, and patching. Then we have a performance tuning and capacity planning for the clusters that I mentioned. Additionally, you have other tasks like monitoring the Hadoop cluster and deploying the security features through Kerberos authentication. Okay, so how does it work? What does Edureka provide? Edureka provides live online webinar classes, and you get this class recordings directly in your LMS. And we have a 24/7 post class support as well, where you mention your query, and then you will get your answers as soon as a technical person adheres to it. You have module-wise questions, you have project work, and in the end, you have a very well certificate from Edureka that you have worked on Hadoop. Okay, so we are still working on this technical issue. Give me a minute here. I'll try to look into what is the main concern for this. Still trying to work on these virtual machines. I'll try to reboot them and bring them back again with a little more RAM. So in the meanwhile, you can have a 10 minutes break. We will join after 10 minutes. Yeah, hi Sarat. We are working on the same issue. The name node HA cluster remains unresolved. Guys, I have just restarted the virtual machine while you guys were away. And I think it is giving the same issue. We'll just look into this issue again. I just started up the virtual machine, but probably there is some issue in the configuration file. We just check once. HDFS site XML on Hadoop DFS name of directory is correct. right. HA cluster is right. HA cluster, HA NameNode and SNameNode, and let me see for SNameNode and HTTP address where it says some issue. Enable the constructor. For HA cluster remains unresolved. For ID NameNode. For HA cluster remains unresolved. This looks fine. Hi Shubhajit. Uh, we do not have any other VMs as of now. So guys, what I will do is probably I can send you all the instructions how to set up this node manager, and we will send you a demo again when I have reconfigured this virtual machine and try to run it again. Probably some issue with the file system, I guess. I have just formatted everything and fresh build up. Probably this is an existing virtual machine that I was using. So probably I will build up a new virtual machine and set it up and share the video with you guys. Uh, systems. Just checking, guys, if the uh, firewalls are off for the system. Yeah, everything looks fine for me. Okay. Hi guys, we have tried to configure the systems again, but it seems that we have run into like a VM issue. The virtual machines are not performing as we have expected. However, we have already different slide that we have prepared from a previous session. We will be sharing that with you, and we will be sharing a script file how to prepare the virtual machines and high availability on your own. I hope, guys, you enjoyed the session. However, we ran into a small technical issue, and that is why we could not complete the configuration. But mostly, we will look into the other. We have looked into all the configuration parameters. Mostly, this is a virtual machine issue. The virtual machines that are built on our small desktop, so they will not be having that power. And there was some configuration issue. I tried in the morning to set it up. Everything was running fine, but we will not. We have not been able to set it up through this session. Extremely, my hearty apologies for that, and hopefully, but that's the daily work for us. Every day we need to look into some issues or the other, and probably we'll try to fix this. And hopefully in the next session, whenever we join, we'll look into the full configuration with the HA for NameNode and the resource manager. Okay, thank you guys. Hope you enjoyed the session. Have a very good night, and hopefully we'll meet soon. Bye bye.